Welcome to the final video in the FISOP training series on European fire safety regulations for sandwich panel products. In this video, we will discuss the conditions of direct and extended applications of fire test results. Direct field of application of test results means using the results from a fire test to cover small changes in the product or how it will be used as long as those changes are allowed by specific rules. For example, if a sandwich panel is tested for fire resistance, the test result might still apply if the panel's color or coating changes, as long as the rules say these changes don't affect fire safety. For extended field of application of test results, this involves using the results from a fire test to predict how the product would perform with larger changes or different uses based on rules or calculations. For example, if a thicker version of a sandwich panel is needed, the extended application uses test results from the thinner panel to estimate how the thicker one will perform in a fire without needing a new test. So, in short, direct applications cover small, rule-defined changes, while extended applications cover bigger changes using calculations and predictions based on existing test results. This slide explains the direct applications of fire test results for non-load-bearing panel walls, emphasizing the conditions under which results can be applied to similar constructions. Test results remain valid for constructions with minor modifications as long as stiffness and stability are maintained according to design codes. Here are some of the allowed modifications: decreased height of the wall, increased wall or material thickness, reduced dimensions of boards or panels excluding thickness, increased number of vertical joints, adding installations, for example, for sockets or switches, increased height or width of the wall under specific conditions. For more detailed rules, refer to Annex A and Annex B of SFS EN 1364-1. This slide explains the extended applications for fire resistance test results for non-load-bearing sandwich panel walls as outlined in SFS EN 15254-5. It highlights the parameters that allow the application of test results to other construction products. For material changes, Table 1 includes modifications to metal facings, adhesives, and core materials. For constructional changes, Table 2 lists down the parameters relevant to extended applications, which include changes to span length or orientation, variations in panel width or panel thickness, including core thickness, modifications to joint construction or fixing systems, changes in the length or height of assembly, and finally changes to the support structure. These parameters ensure flexibility while maintaining compliance with the tested product's performance standards. Here is an example of how test results are extended for the span length of a wall panel. First, let's define what is overrun time. It is basically the period of fire resistance beyond the intended classification period achieved in the test. Let's give an example. The test result for a construction product is 135 minutes for a tested span length of 3 meters. The overrun in this case is less than 20% compared to EI 120 classification. So the allowed span length for this classification is the tested span length plus 1 meter according to direct application rules. Another example, compared to EI 90 classification, the overrun now is more than 35%, and therefore An extension in span length is allowed for this fire resistance classification according to the rules shown in Table 4. And that gives us an extended span length of 7.5 meters for EI90 classification, without additional tests with longer spans. For calculating the allowable span length of a ceiling panel, this equation is used. First, we determine P by using the temperature, deflection, and span from the reference test at the desired classification temperature. And then we calculate L assuming the same maximum deflection as in the reference test. And then we compute the span for the desired temperature using the calculated P. And finally, we verify that the span length applies to fire resistance and it also meets the structural requirements for normal conditions as a sandwich panel. In this example, a ceiling panel of 5 meters is classified as EI90 based on the fire test results. Here is what we know from the test. Now we want to know how much a ceiling panel can be extended for EI60 classification. First thing is calculating the deflection of the panel in 60 minutes interval, which should be lower compared to 90 minutes fire resistance test interval. After that, we find the P, which is a theoretical value for the relative end movement. Now, assuming we want to extend the panel to be 10.9 meters. Then in the second step, a new deflection is calculated, and now you can notice that we are making sure the calculated deflection is lower than 440 millimeters, so we are able to use the fire resistance test results for EI90 to extend the span length of the ceiling panel. After achieving that, the catenary force is determined using this equation. The number of fasteners is then calculated accordingly. Conclusion is that the allowed extended span length for the EI60 sandwich panel can be up to 10.9 meters using the test results from the EI90 minutes tests for similar sandwich panels from the same family. Lastly, the catenary forces will have to change to accommodate for the increase of span length and weight of the panel. When applying the fire test results of load-bearing roof panels under EN 1365-2, the following conditions must be met. First, maximum moments and shear forces calculated for the roof panel must not exceed those tested under the same loading conditions. Minor modifications to the ceiling structure beneath the roof are acceptable, provided they do not change the tested configuration significantly. Another condition is that the cavity height and spacing between the ceiling and structural members must be at least equal to or greater than the tested values. Finally, no additional materials can be introduced into the cavity unless the same weight and fire load were accounted for in the tested specimen. Direct applications for load-bearing roof panels under EN 1365-2 also depend on the roof's inclination. For trussed rafter roofs, the bottom chord's inclination must match the tested angle with a tolerance of plus minus 5 degrees. For roof with purlins, if tested at less than or equal to 10 degrees inclination, the results apply to angles from 0 to 80 degrees in practice. For apex or monopitch roofs, the inclination tolerance varies based on the tested angle. This table shows the required angles. The sandwich panel standard EN 14509 offers no additional rules for fire resistance direct applications in load-bearing roof panels, nor do external standards exist. Roofs also require classification for external fire performance, which may involve further testing as outlined in other standards. This is the end of FISAB training video series. I hope by the end of these videos you have gained some practical knowledge about the fire safety for sandwich panel products. Remember always to use the latest versions of EN standards.